mouse up here just in case. This covers everything since the last common assessment. It's I think exponential and logarithmic functions was unit 7, if I remember right. So that's kind of where it starts. It's got that stuff about exponential logarithmics. It's got stuff about that unit 8 that we had that was real short and weird because it was just 2 topics about rate of change and rational functions. Then the trig stuff. A lot of this, the graph questions always kind of refer back to that form that we've got where you've got, you know, x minus h and then plus k somehow. H is horizontal shift. And k is vertical. So when you're looking at a question and it's talking about transformations, that's the things to look for. With these exponential ones, the x plus h is in the exponent and then the minus k or the plus k is afterwards. So things to look at on these exponential, the 2, that's a stretch. It's shifted, let's see, it's x minus 1, so that means it's right 1. And then the minus 1, that's k, so it's down 1. Domain for exponential functions is always pretty much everything because you can plug any number in there. The range is going to be from k up. So that's how you would note that. And to graph it, again, the way that we graph stuff, because we can, is we go to the calculator, type in the function on our y equals, this is where I need the piece of paper, 2 times 3 to the x minus 1, and then minus 1. So there's your function straight from the paper. You go to graph it, and it looks like that. Common assessment, of course, is going to be multiple choice. It's going to be on a Google form. So it's just a matter of looking at it and making sure it matches. Probably be some that have similar shapes. So a way that you can check the actual numbers, as always, go and look at the table. You can see here it doesn't go past, ooh, I've got this one in radians. Let me fix that. There. Okay. See, the y, it gets to -1, but it never goes past it. So that's why we've got our domain and range. For some specific points, you got 1, 1, 2, 5 that you could graph or you could check on the table. So here, 1, 1, 2, 5, and then there's my basic shape. And that's how you graph it. Okay. You look at the transformations. You got the basic shape of exponential functions. If it's an increasing exponential function, it's going to look like that. If it's a decreasing one, it's going to look like that. You just have to kind of place it on the XY axis. Or, as I said, since it's going to be multiple choice, you've got to match what shows up on your calculator. Here, that's going to be left 2. It's going to be stretched by the 5. And then down 1. Go to the graph. Here I've got the 5, the base is 2, x plus 2, minus 1, I got, let's see, -2, 4, -1, 9 are a couple of good points. It's going to go down to -1 just like the other ones. So there's my graph. Domain, again, -infinity to infinity. Range from -1 to infinity. And I oops that other one, it should be -1. Okay. 3 and 4 are logarithmic functions rather than exponential. Okay. Here, that 2x plus 9, you set that equal to 0 to find the starting point for your domain. So I'm going to get -9 halves. The domain is all of the x's from -9 halves up. Get whatever's inside the parentheses, set it equal to 0. Range is going to be all real numbers. Well, in fact, let me just write all reals because I think that's more likely to be in the notation. Go and graph it. Okay. Remember to type in a logarithm. It's alpha window 5. Because it's a logarithm that's not base 10 or base n, or base e, sorry. So I put the 3 down here, and then the 2x plus 9. Graph it. Looks like that. Remember, the calculator doesn't show it, but it does go infinitely down right there. Look at the table to get a couple of helpful numbers. -4, 0, -3, 1, 0, 2. Looks like that. Number 4, same process. In fact, it's still log base 3, but it's 2x plus 6. And then I've got a plus 3 out here. All right. So the domain, again, set 2x plus 6 equal to 0. You're going to get the domain is all the x is greater than -3. The range, again, is all reals. It's shifted up 3 by the plus 3 after it. If I look at the table and get a couple of good points. No. There are not any really good ones here. Yeah, there's not really any good ones. At 0, so let me go to 0 and -2. Because those would be some good spaces. I'll just have to kind of fudge them a little bit. All right, so at 0, about 4.6. At -2, 3.6. So right about there. Right about there. And there's your general shape. Okay. Again, the graphing on the multiple choice, it's a matching game. You graph them on the calculator, you look at the table, and you try to match it to what you see on screen. Okay. 5 and 6, solve the equation. This is properties of exponents. You have to rewrite the things so that they have the same base. Okay. 1 over 81 is 3 to the -4th. 27 is 3 to the 3rd. And then both of those are taken to the 3r. And if you don't know, like I don't know what power of 381 is, you try to figure out the base, and that's when we use the calculator. you type in 3 to the x, and then look at the table and find where the 27 and the 81 are. 27 is 3 to the third. 81 would be 3 to the fourth. Because it's flipped, it's -4. Now I can basically ignore the bases and just say -12r equals 9r, because -4 times 3r equals 3 times 3r. Solve that equation, you get r equals 0. Because if you add 12r to both sides, you get 21r equals 0, divide by 21, and r equals 0. Number 16 is going to work similar, except it's base 2. 16 is 2 to the fourth. 32 is 2 to the fifth. And that's taken to the -3n minus 3. Which, again, I ignore the 2's and just look at the exponents. 4 equals -15n minus 15. Because I have to distribute that 5 to both parts of it. Add 15 to both sides, I get -15n equals 19, and so n equals -19 over 15. That's the solvent. So one or two of those where you have to find the common base and then change it to an exponential expression. Option, of course, when you got multiple choice questions, is you've got 4 or 5 answer choices, plug them in and then see which ones work. If you're looking at it and you're stuck, like you can't, you're saying, I don't know which base to use, then just try some of the answer choices and see what works. All right. The next few are just the basic definition of logarithms. We've talked about that. I'll write it over here. If you have b to the x equals a, then the switch makes it log base b of a equals x. The b becomes the lower number, the other two things switch sides. So that's what I'm going to do here. Log base 4 of 16 equals 2. That means 4 squared equals 16. Log base 15 of 1 over 225 equals -2. That means 15 to the -2 equals 1 over 225. Notice I'm not changing or evaluating anything. I'm just rewriting it. Because that's what the instructions say. It's switching it to the other form. And then here in 9 and 10, that's the same number. This is going to be log base 15 of 1 over 225. Again, switch sides. And number 10, log base 19 of 1 over 361 equals -2. All right, 11 through 14. It solved the equation, and with logarithmic equations, they can be more difficult, but these are pretty straightforward because in each of them, you can kind of just ignore the logarithms. Because when the logs have the same base, you don't have to change anything. If it's log base 2 of this equals log base 2 of that, that means the things in the parentheses have to be the same thing. So this means that 5b plus 6 equals 4b minus 3. Some quick algebra, some rearranging. Subtract 4b from both sides, you get b. Subtract 6 from both sides, you get -9. Okay. Number 13, similar. Negative m plus 5 equals 8 minus 4m. Add 4m to both sides, you get 3m. Subtract 5 from both sides, you get 3, which means that m equals 1. Number 12. Again, if the log bases are the same, you can just ignore them. So this leaves 4x plus 6 equals 6 minus 5x. Add 5x to both sides. Subtract 6 from both sides, you get 9x equals 0, which means x equals 0. And here at number 14, again, same thing. If the logarithms are the same, then you just set the parentheticals equal to each other. Add 2b, subtract 6, I get 5b equals 4, which means b equals 4/5. Okay. The next two are exponential equations rather than logarithmic. But what we need to do is to change it to a logarithm, because we've got to get the variable out of the exponent. So, number 15, first I'm going to divide by the negative 10. That will give me 11 to the h minus 6 equals 6.56. Then I'm going to change it to a logarithm. I'll have log base 11 of 6.56 equals h minus 6. That log base 6 or log base 11 of 6.6 is a number. So I go to my calculator. Alpha window 5. What was it again? Log base 11 of 6.56. 0.78 something. I'm just going to go with 0.7844. So I got 0.7844 equals h minus 6. That means h equals 6.7844 because you just add 6 to both sides. Number 16 is going to work similarly. Add 1 first, and I'm going to get 13 to the r minus 2 equals 41. Change it to a logarithm, and I get log base 13 of 41 equals r minus 2. Evaluate the logarithm. Log base 13 of 41 gives me 1.4478. Add 2. Okay. If you have a variable in the exponent, you got to change it to a logarithm to solve it. If you happen to have a variable in a logarithm, you have to change it to an exponent to solve it. But when it's log equals log, you can just ignore the logarithms and solve based on what's in the parentheses, if the bases are the same. All right. 17 and 18 are word problems, but here's a formula. So you've got to figure out what goes where. Value of a house is $175,000. That's the A in the formula. R is the 3.5%, so that's 0.035 when I go to put it in there. And T is 12. So A, R, and T, and I just have to plug it into the formula and evaluate it. So that's going to be 175,000 times 1 plus 0.035 to the 12th. And I calculate that. $264,437.02. Okay. R is the interest rate. A is the starting amount. And then T is time. In this problem, we're looking for the amount in the account, the principal, that's where you started off with. So this is P. The 0.065, the interest, that's R. T is 9, but here the N, that's the number of compoundings per year. So that's kind of a little added extra wrinkle in this question. How many times is it compounded per year if it's compounded quarterly? Yeah, 4. So that means N is 4. So when I go to set it up, I have A equals, or well, my amount equals 7,500, 1 plus 0.065 over 4 to the 4 times 9. Okay. Read through the question, identify what's what, write it in the formula, and then we're ready for calculator. So 7,500 parentheses 1 plus alpha enter 0.065 over 4, close the parentheses, to the 4 times 9. Okay, everything typed in like I had it written. Press enter, and there's your amount, 13,399.28. All right. Average rate of change, and this was from that quick little unit 8 that we had. Was it unit 8 or did I call it unit 9? Okay. It's been long enough, I don't remember. But it was the unit where we really only had 2 lessons. There was one on rationals and one on rate of change. This is rate of change. The formula is y2 minus y1 over x2 minus x1. You're given the 2 x's, okay? What you're given is, it's not an ordered pair, it's the interval of the x's, x1, x2, and x1, x2 here. What you have to do is use the formula, use the function to find y. So y1, plug in x1 into the formula, that's -2 squared plus 14 times -2 plus 45. Y2 is going to be 4 squared plus 14 times 4 plus 45. Over here, plug in the -3 first, so y1 equals -2 times -3 squared minus 20 times -3, oops, minus 51. And y2, you plug in 0, you get -2 times 0 squared minus 20 times 0 minus 51. Okay, again, this is using the function to evaluate. I'm just going to use one of these. You see how to do it. I'm just going to type these in. All right, so for the first one at -2, I get 21. At 4, I get 117. So this is going to be 117 minus 21 over 4 minus negative 2. Y2 minus Y1 over X2 minus X1. And I get 16. For number 20, again, negative 2x squared minus 20x minus 51. The first one, when I plug in negative 3, I get negative 9. When I plug in 0, I get negative 51. And then I take those numbers, plug them into the formula, the slope formula, y2 minus y1, negative 51 minus negative 9 over 0 minus negative 3. Negative 14. Okay. You're given your two x's, you're given the function that you can use that to find your two y's, and then you use the slope formula for the range. Or not the range, for the rate of change. '21 and 22 and 23 and 24 are identify the transformations. Your standard rational function is 1 over x minus h plus k, or a over x minus h plus k, where a is the dilation. It's either a stretch or a shrink. And if a is negative, then you've got a reflection. So all of the things going on here, that negative reflects over the x-axis. It is stretched by 2. It is shifted right 3 by that minus h in the denominator, and then the plus 3 shifts it up 3. Again, this is just remembering the forms, and well, really, it's looking for a, h, and k. We have looked for and sought out a, h, and k in every function that we have dealt with. Okay. All right, number 22. There is no reflection. We've got a stretch by 4. It is shifted left 1. Remember, the form is always x minus h. So if you have a plus, that means h is negative. So it's left 1, and then that plus 2 makes it move up 2. Okay? '23 and 24, you get the same process. The negative reflects over x. The plus 3, that's left 3, and the minus 2 is down 2. Here, the 2, that's a stretch because it's up there in the numerator. There is no left or right shift because it's just x. That means h is 0. And then the minus 1 moves it down 1. Okay. Again, the f of x equals a over x minus h plus k. A gives you information about the size change. Is it stretched or shrunk? X is horizontal shift, k is vertical shift. I don't domain, not low main. All right, with the rationals, when you go to graph them, again, we're going to graph them on the calculator, we're going to use some functions. But basically, or use the table function. Basically, though, you're looking at the asymptotes. The stretches and the shrinks, I mean, they don't really do much with a rational function. The major thing is the asymptotes. Identifying the domain and range, you look at h and k. The domain is going to be everything except h. The range is going to be everything except k. And so those are kind of your asymptotes that you can use to sketch the graph to figure things out. So here in number 25, my domain is all the reals except one. And the range is the reals except one. So I'm going to go here and draw an asymptote at x equals 1. I'm going to go here and draw an asymptote at y equals 1. And then I would look at the negative. That means it's going to be reflected. So here is basically my graph. Without even having to go and look at the calculator, just knowing the asymptotes. Okay. Now I am going to graph it on the calculator for verification because why not? You've got the calculator in the test, so why not use it? So just so that we can see that that matches up, and for a little extra practice with the calculator, I've got the negative, and then the fraction 4 over x minus 1 plus 1. Graph it. And you can see it matches what we've got there. Okay. Again, the critical thing with these rational functions is the asymptotes, figuring out h and k. All right, so here on number 26, the domain, the reals except 0. Because there is no h. When you don't see h, when it's x, just x by itself, that means it's x minus 0. The range is the reals except 2. So I sketch in my asymptotes here and here, and then draw the graph. If looking at the picture is going to help, graph it on the calculator. If looking at the table is going to help, look at the table. And you've got them, we're going to use them. All right, from here on out, it's trig stuff. You know, the trig unit was a big unit, y'all know that. And it's a big part of what we have done since the last common assessment. So it is a major portion of the test. But that's helpful because it's what we've done most recently. Formulas. I mean, here in 27, whatever, 27 through 30. Formula's right there. You know, use A equals 1/2 AB sine C. Remember, the key thing there is it's the angle formed by the two segments that you know. So you're just plugging them in. So here, area equals 1/2 times 6 times 8 sine 1/16. Here, area equals 1/2 times 8.4 times 14.2 sine 34. And that's all I'm doing right here is I'm just setting up the equations, because once I've got the equations set up, it is calculator. So area equals 1/2 times 7 times 14 sine 126. And then area equals 1/2 times 14 times 12 sine 38. So set them up. Formula's right there, and you've got the segments that make up the angle right up in place, and then it is calculated. I'm going to type one of them into the calculator here on screen just to demo it, and then I'm just going to type the other ones to get the numbers. Look at the calculator I've got on screen. What's wrong with it? It's in radian mode. For these, when I am dealing with degrees, I mean, that's the thing. When you look at the triangle that you're working with, look at it. Is it marked in degrees or radians? Whichever one is marked in, that's what your calculator needs to be. So remember, we press the mode button, go down here to where it says radian, change it over to degree. Otherwise, you're going to type in the calculator, you're going to get an answer that doesn't match any of the multiple choice answers. And you're going to think you did something wrong, when really it was the calculator just not set right. So 1/2, let's see, what was that first one? 6 times 8 sine 16. $21.6. Square kilometers to fit the units. Okay. Pay a little bit of attention to the units. I talked about this when we first went over this stuff in the Unit 12 packet. Because when it comes to multiple choice questions, it may be that there's a difference in units. That's the only difference in the right and the wrong answer. 28, the area is 33.4 square inches. 29, 69 square yards. And number 30 is 39.6 square feet. Again, all of those, it's the area formula, 1/2 AB sine C. Fairly straightforward calculator. It's a formula and a calculator. And I'll remind you, you don't get to use the study guide on the test. We're doing this so you can see what's on there and practice it. So, because it's a common assessment. All right, what do we do here? Finding the measurement indicated, whether it's an angle or a segment, these are, well, let's see, A, B, I'm sorry, 31, 32, 33, 34. All right, 31 through 34, it's law of cosines. The other ones there are going to be law of sines. Law of cosines, you're going to have an angle opposite a segment. I'm sorry, law of sines, you'll have an angle opposite a segment. That's how I can tell the first four are law of cosines, because I don't. So here I'm looking for AB. Well, that's little c, really. So what I'm going to use is law of cosines, c squared equals 13 squared plus 29 squared minus 2 13, 29, cosine 41. Evaluate it. and take the square root. Remember to take the square root. 31, similar. C squared equals 12 squared plus 26 squared minus 2 times 12 times 26 cosine 40. So I'm going to go ahead and work one of those to the calculator. Don't forget to take the square root, though. That can be a big deal. And I would venture guess that one of the incorrect answers would be the one where it's not the square root. So be aware of that. So here, number 31, let's see, 12 squared plus 26 squared minus 2, 12, 26, cosine 40 gives me that number. Then I have to square root of it. Okay. I mean, keep in mind, when you look at the picture, if one of them is 12 and one of them is 26, the other one probably is not 340 something. So make sure the numbers make sense. So the square root, again, I hit second x squared, and then to just use the number you just had, if you hit second and the negative sign, it copies the answer. So there. So 18.5 for this one. Not square feet, just feet. 32, same process. You go through it, type that stuff in the calculator, take the square root. That one's going to be 21 feet. Again, I've got it set up. You can practice typing in the calculator if you so choose. For 33 and 34, these are probably the most complicated ones we've got, because they're the ones where we have to use the law of cosines to find the missing segment, then use the law of sines to find the missing angle. So of the problems that we've got on this common assessment, these are going to take the longest, because it's two formulas. Okay. So first, I got to find this segment using law of cosines, then use the law of sines to find the angle. I'm looking for this angle over here. So I'm going to set up the law of cosines. X squared equals 10.9 squared plus 25 squared minus 2 times 10.9 times 25 cosine 78.4. Type that into the calculator to get a number. Yeah, just like I worked in 31 and 32. Okay, so I get X is 35.8. And now I need to use the law of sines. I'm going to say sine C over 10.9. Remember, when it's law of sines, it's the angle opposite the segment. So sine C over 10.9 equals sine 78.4 over 35.8, the x that I just found. Cross multiply, that's going to move the 10.9 over here. So sine C equals 10.9 times 78 or sine 78.4 over 35.8. But I need C, not sine C. So this is where we have to inverse sine it. So let me go to the calculator. In fact, let me type it in here on this handheld. Then I'll type it on the other one so that I have everything right. Again, make sure your calculator is in degree mode when we're doing these. Okay. I'm going to go here. Second sine. When you're trying to find an angle, you have to use one of the inverse trig functions. So second sine, and then my fraction inside here, 10.9 sine 78.4 over 35.8. And I get 17.4 degrees. And that's how it works. No, it's not 35, it was 34. What was it? 17.4. All right. 34 works the same way. So I'm going to go through the setup and then write the answer. You've got x squared equals 15.1 squared plus 24.3 squared minus 2 times 15.1 times 24.3 cosine 117.3. And then you use x to find that. But here our bottom line, angle B is 15 degrees. No, 23.3 degrees. I'm looking on the wrong line. Yeah, you've got to use the law of cosines to find a missing segment, and then use the segment opposite, and the segment and the angle opposite each other, and the law of sines. All right. 35 through 38 are just straight law of sines. You got to, again, angle opposite the side. So if I'm looking for angle C, that's going to be sine C over 23 equals sine 102 over 35. So that means sine C equals 23 sine 102 over 35, which means C equals the inverse sine of it. So this is where I go to the calculator. 23 sine 102 over 35. And that, well, 39.99, whatever, that's basically 40 degrees. Okay. For angle A here, number 36, that's going to be sine A over 9 equals sine 102 over 34. Sine B over B, the angle opposite the segment that we need. Work that one out, you get sine A equals 9 sine 102 over 34. So there are a lot of basic algebra as we work through this. And then this one, A equals 15. And then here in the other two, I'm using the law of sines not to find the angle, but to find the segment. So I'm not going to have to do inverse sine stuff. So here I've got sine 127 over 17 equals sine 25 over AB, the segment that I need. So that means the segment AB, which is actually little c, let me call it little c. C equals, the 17 goes up top. and the sine 127 goes on the bottom. Type that straight up in the calculator, you'll get 9. 38, I'm looking for BC, that's this segment over here. So sine 98 over x equals sine 47 over 14. So x equals 14 sine 98 over sine 47, 19. Degrees to radians, it's radians over pi equals degrees over 180. And keep in mind, if there's a pi in it, don't use it in the calculator. Just kind of ignore it. And if there's not a pi in it, then, I mean, if it's a degree mode and you're converting it to pi, then just do the 110 or the degree over 180 and then divide or multiply by pi. So essentially, if you need to know r, it's degree over 180 times pi. And if you need to know the degrees, it's r times 180 divided by pi. Okay, so number 39, 2/3 times 180. That's it, because you're the radians here. The radians are 2 pi over 3. So I divide out the pi, that's going to be 2/3 times 180. Okay, and again, you can calculate these. Nothing wrong with that. I'm just going through it because these are simpler things. Number 40, divide out the pi, you're going to have 180 over 36. Okay. If it's radians, you divide out the pi and then multiply by 180. Pi over 6 times 180, that means it's 180 times 1/6. That's just 30 degrees. For the degree ones, set them up as a fraction. 110 over 180 times pi. Again, don't multiply it by pi. I mean, don't multiply it by the 3.78 whatever in the calculator. Just use the symbol. This one will simplify to 11 over 18 pi. Here, the 555 over 180. And then you just write pi next to it. Again, you can use the calculator. I'll do that one for this one. 555 over 180. Simplifies 37 over 12, and then I just write pi next to it. And the last one, 120 over 180. That's 2/3. Or 2 pi over 3, same thing. All right. For graphing, amplitude is A, period 2 pi over B, right? So here, vertical shift is 1. The amplitude, since that's right there, amplitude is 1. And the period is just 2 pi. Again, our general form here, it's A sine or cosine bx plus k. A is the amplitude, 2 pi over b is the period, and k is the vertical shift. And then you graph them and you schedule a graph. Make sure you do zoom trig, sine theta plus 1. A lot of folks get messed up with this one because they think they have to type theta. No, you don't. Just do sine x plus 1. Graph it. But again, press the zoom and 7. And for graphing, make sure your calculator is back in radian mode. So it looks like that. Okay. The key thing for matching it to a graph and a multiple choice thing is look at where it crosses the y-axis. Okay. When you graph it on the calculator, just look at it and see if it matches. So that crosses at 1. So I just make a little graph here. And it basically like that. Sine theta over 3 minus 1, that's going to be shifted down 1. Amplitude is 1, and period, 2 pi divided by 1/3, that's going to be 6 pi. So this one's pretty wide. Like that. (47) has an amplitude of 1/2, a vertical shift of -2, and a period of 2 pi over 4. That's going to be pi over 2 when you simplify it. So this one's pretty quick. And it's also down 2, so that's not great. But again, I'm trusting you to use the calculator, graph on the calculator, and match it to a multiple choice option. And if it's stating the amplitude and the period and the vertical shift, then these pieces of information are also helpful. This one's real big because we got an amplitude of 3 and it's shifted up, so it's at 5. Pretty frequent here. Okay, so that's graphing. Oops. The next 4 are just straight up trig functions. Here is a picture, use the trig ratio. Remember, cosine is adjacent over hypotenuse. This is the hypotenuse. This is the opposite. This is the adjacent. So here you need to find the adjacent using the Pythagorean theorem. So this will be 17 squared equals 8 squared plus a squared. That's 289 equals 64 plus a squared. So a squared is 225. That means a is 15. But now I have to use that to find the trig ratio adjacent over hypotenuse. So cosine theta is going to be 15 over 17. Again, I had to use the Pythagorean theorem to find it. Similar here in, well, number 50, I don't know this segment up here. I don't need it. I need opposite and hypotenuse for sine. So that'll be 9 over 15, which simplifies to 3/5. Number 51, again, opposite over hypotenuse. That's going to be 5 over 5 square root of 5. You can't leave a radical in the denominator, so you have to multiply it by square root of 5 over square root of 5. That leaves 5 square root of 5 up top, and on the bottom, 25, which then simplifies to square root of 5 over 5. That's just rationalizing the denominator. And number 52, tangent. Tangent is opposite over adjacent. Well, I don't know the opposite here. So I have to use Pythagorean theorem to figure it out. So I'm going to go 5 squared plus b squared equals 13 squared. All right, so I use Pythagorean theorem. I figure out that the other segment is 12. Now I can do opposite over hypotenuse, 12 over 5. I'm sorry, not opposite over hypotenuse, opposite over adjacent, because it's tangent. So sometimes you have to use Pythagoras. A squared plus b squared equals c squared. And remember, c is always the hypotenuse. Which one's a and which one's b don't always matter, but c matters. Okay. Last one here, we are doing inverse trig functions. Here you've got the opposite and the hypotenuse. Opposite over hypotenuse is sine, so this is going to be inverse sine 20 over 33. Number 54, I have the adjacent and hypotenuse, so this is going to be inverse cosine 26 over 37. And it does say the nearest degree, so when we go to the calculator, we have to make sure it's back in degree mode. Here, I've got the opposite and the hypotenuse, so this is going to be inverse sine 16 over 17. And this is opposite and adjacent, so this is going to be inverse tan 49 over 14. Okay. Again, these last few kind of seem out of order. It's like they should have been the first part of the trig questions, because this is kind of where we started, but, you know. So yeah, now calculator. Inverse sine 20 over 33. I didn't put it in degree mode, so I'm going to do that real quick. There we go. 37.3 for that one. It says to the nearest degree, so I'm just going to go 37. And then inverse cosine 26 over 37. Gives me 45. Inverse sine of 16 over 17. Is 70. And inverse tan, 49 over 14. $74. That's how the inverse trig functions work. Yeah, those, here's a picture, type it in the calculator. Pretty simple. All right, let me get the mouse. Go over here. Stop presenting. Stop recording.